So for this video over here, we'll be talking about odd and even functions. So we're going to define what they are first, and then we're going to talk about how to actually see whether a function is odd or even. So first of all, we'll go for even functions, a little bit simpler. So we're going to look at an original function f of x, and we're going to see f of negative x. So what does the negative here over here mean? It means that if you put negative x instead of x every time you see x in the function, then we're going to have a reflection in the y-axis. So I'm just going to call this r subscript y, because it's a shortcut. And this also means that if it's reflected in the y-axis, then this means that this function is going to be symmetrical about the y-axis if these two are equal to each other, since the original is going to be equal to its reflection. Now, let's have a look at a parabola over here. We can easily see that a parabola with a turning point at 0, -1 is going to be symmetrical in the y-axis. But it's not just about a visual proof. We need to look at the algebra and see what's going on. So we need to prove that f of x is equal to f of negative x, which is the reflection in the y-axis. So we know the left-hand side is equal to this one over here, x squared minus 1. Now we're going to need the right-hand side of the equation to equal this. So right-hand side is equal to, we're just going to slot negative x into our rule here. So we have negative x all squared minus 1. Taking the negative of the square of a negative, sorry, going to give you positive x squared minus 1. And you can see that these two are the same. And all we need to say is the right-hand side is equal to the left-hand side. And we're done over here. Because if you prove that this equation here is true, then this means that this function f is symmetrical. Sorry, not symmetrical, it's even. Okay, so for an odd function, a little bit more complicated since there's the extra step of finding not just one transformation to your function, but two transformations. So you're not working with your original function anymore in the equation. You still have a reflection in the y-axis, but when you have a negative in front of your function, this is still a reflection, but it's a reflection in the x-axis now. So we're going to be flipping it upside down. So we need to see that the graph is going to look the same after you flip it from left to right, as well as when it looks upside down. Okay, let's try this cubic over here. So it's got a rule of x times x plus 1 and x minus 1. So you can see that if you flip it upside down, and then, or if you have the original function and you flip it from left to right, they're going to look the same. Just take a moment, pause the video maybe, just have a think about how that goes visually. Once you can consolidate that, you might want to go through the algebra proof here to prove that this equation is true and to state that it is an odd function. Okay, so we need f of negative x equal to negative f of x. So let's work with the left-hand side first. Okay, so we're slotting in negative x every time we see it. So we have negative x times negative x plus 1 times negative x minus 1. I won't touch the negative out here, but what we're going to do is we're going to take a factor of -1 out of each bracket over here. If we do that, it means that we're going to have -1 times -1 outside, since we're taking -1 out twice. So what's going to happen is you're multiplying by 1. So this is going to be equivalent to x minus 1 times x plus 1. So using two lines there for one expression. Okay, so we're going to need the right-hand side to equal to this one over here. So let's separate this. Okay, so the right-hand side is a lot more simple. All we're doing is we're putting a negative in front of f of x. And so we're multiplying all of our function by negative 1. That's what we're doing here. And if these two look the same, you can say the right hand side is equal to the left hand side, and conclude that this is an even function. Okay. Alright, so let's look at some examples here where we need to state whether the function is odd or even based on the rule. So we have f of x equal to sine x here. Now for sine x, we can think about it visually again. Just going to draw some lines to show that my amplitude is 1 over here. Just a quick sketch, doesn't need any scale. So sine of x looks something like that, but remember, if you're not restricting the domain, it goes on infinitely throughout to negative infinity and to infinity. But I'll just stop here to show you that what are the possibilities of this being an odd or even function. So if I flip it from left to right, does it look the same as the original function? Maybe, but if it's a bit hard to visualize, just go through these possibilities and see what's happening. So we're going to be evaluating f of negative x and negative f of x and comparing all of these results. Okay. So f of negative x. Now we're just chucking a negative sign inside our bracket. So we have sine of negative x. Through your unit circle, you know that if you have sine of negative x, this is also equal to negative sine x, since it's in the fourth quadrant, if x is, of course, between 0 to pi on 2. Okay. Now if you have negative f of x, and we're doing this because we already know that negative sine of x isn't equal to positive sine of x. Those two are quite different, so it can't be an even function. So let's test to see if it's an odd function now. Okay, so all we're doing now is we're putting a negative in front of sine x, and you can easily see that these two are the same. So if f of negative x is equal to negative f of x, then we can conclude that this is an odd function. Okay, so if we go over here, there's f of x equal to 1 on x squared. So this is going to be a truncus. Deal more with these graphs again, but just a recap. Kind of like a hyperbola, except it's going on both sides of the y-axis, and for a positive one, it's above the x-axis. It looks something like this. You can easily see it's symmetrical over here, just visually. But of course, we need to go through the algebra again, just to double check. Because when we sketch, not everything's to scale. We want to be exact in our calculations. So, first of all, we'll check f of negative x to see if it's an even function, since it does look like one at the moment. So slotting in a negative x at the bottom, and we square that, that's going to give you 1 on x squared. So if these two are equal to each other, the f of x equal to f of negative x, then you know that this function is even. Alright, that's about it for odd and even functions.